solid-state devices?
Well, so basically we're doing a couple things. We're going to start supporting solid-state devices as a second-level cache, as well as devices in the pool. So today we have solid-state devices. This is a storage media type in the storage pool. We'll be adding support for solid-state devices to be used as a second-level cache. And our next-generation hardware platform will be supporting PCIe flashcards, and that'll give us the ability to, in that platform, you can be able to attach drawers of PCIe flashcards. So you'll be able to get a lot better performance from a second-level cache in that way. With the introduction of MQFS and SLAT, both those technologies will also give much better utilization of the solid-state devices.
Okay. I'll add something to that. Recently, we were benchmarked against a machine that had a terabyte of flash cache in it, and we put in 600 gigabytes of SSD instead. And that machine with a terabyte of flash cache was running an Oracle database that had about 3 terabyte working space, table space. And out of the box, we beat them. It took them 3 days to load their cache for continuous operation. One of the things that we've decided is that we believe that it's important to not just have flash cache, because cache takes a long time for bits in the database to get loaded and get hot, as it's called. So we believe that you get deterministic and immediate performance even after a cold boot with storage classes like SSD, and allow the cache to fill in the blanks where you weren't able to predict that something was going to get hot, and it gets hot over time. There's a lot of your applications that are hot, and you know it, and you don't have to think about it. You know it, you want to pin it there, and that's why we have a multi-level cache strategy, which involves not only flash cache, but also SSD or flash storage. We think it's important to have all levels. Is that fair enough? All right. Another question. When will we support RAID 6?
Well, RAID 6.
You're saying yes.
What's that? No. RAID 6, we'll be putting that into the new SAS drawer that will be coming out. So when we support the new SAS drawer, we'll add RAID 6 into that. The idea is, we'll really need it when we get to the 3 and 4 terabyte device support, and then also the next generation platform, which is based on that SAS drawer, will have RAID 6.
Okay. All right. Let's move on. This is an interesting one. What is Pillar's strategy for long-term deep archive on disk?
Take that.
Okay.
So this is actually a question that's come up a couple times during the session in one form or another. And from what you've seen us present about storage domains is actually the thing that we're going to use to focus on many issues where you have to move and migrate data, and even in terms of long-term archival, you can actually be able to create a storage domain that could be your long-term archive. Now, some people have actually brought up and pointed out to me that in many areas, government regulations are actually prohibiting deduplication or even compression of the data, and yet they have to keep data for a very long time, even longer than even projected lives of media. But that's all more important to think about how storage domains work and being able to essentially migrate the data from one pool to another, even replacing the media over a period of 20 years potentially to keep that going. Might be worth mentioning the sleepy drive types of features. One of the things we're looking at is the storage domains is that you can use low power, lower performance, and slower cost devices. And we're actually putting in the ability within a storage domain at some point in the future to be able to spin them down and power them down so that they don't utilize power while they're actually archiving the data.
I guess I should have a confession on that, because we hear a lot of things about the stuff that we do right, or good examples, and thank you for all of those. But one of the things that I'd say we didn't anticipate properly was we had the feature for sleepy drives a long time ago. Right? That was a name I made up because my kids used to watch this cartoon called Sleepy Bear, big deal. The QoS allows you to arbitrate between lots of different applications in the data center. And you've got this virtualized pool that, you know, lays data out all over to keep hotspots from happening and to make sure you maximize the I/O of the disk. It's very rare that you have any disk in the system that really can afford to be asleep. And that's one of the issues. What storage domains does is it allows us fundamentally to create a domain that serves for some backup data or some jobs that operate temporarily in very, you know, isolated times that you then can use the sleepy drive kind of thing for. Sleepy drives will, of course, enhance the length of time that the media could last. One of the issues that people are working on is long-term archive. You know, tape doesn't last that long. Lots of things can go wrong with it. There are some technologies out there like digital optical tape that are very underdeveloped and not really ready for prime time. It's difficult to come up with a 100-year archive kind of structure. And if you think about that from a global perspective, the world has got a problem. The problem's being created by guys like Graham at the University of Toronto that are putting all the stuff digitally somewhere. And it's becoming thousands of petabytes. And yet it's not on media that's going to last 50 years. So every so often, you've got to start figuring out what you're going to do to make sure that the media doesn't expire and you lose treasure troves like the Library of Congress in the United States or the Toronto Library we just talked about. It's a big problem. Anyway, I think what the storage domains will allow us to do is evolve the media over time. And of course, the good news is it does get more and more dense, more terabytes per square foot, and we'll be able to shrink the space that it takes as we move on, hopefully refresh every 8 to 10 years. All right, next question. When will Clams release his vision of cloud storage? I think, Chris, that's you.
So ask that question again.
When will Clams release his vision of cloud storage?
So we're actually in the process right now at Pillar of not only making sure that we understand the emerging cloud and morphing cloud, but making sure our development programs are aligned with that. And specifically what we're looking at is recognizing that cloud storage has to be hyper efficient, particularly if you're running a public cloud, where I intend to make a profit and do it at lower cost than you can do in-house. So it's sort of the double whammy. It's all about utilization, efficiency, and deterministic performance to meet service level agreements. And this is really what we're going to be focusing on. And you've heard some of the hints of how, with that horrible thing called SLAT, and we want to give you the ability to
You
have.
know how he voted.
We want to give you the ability to have the system itself manage the placement of the data, but the big pillar difference is you assign the quality of service. And that really says that if I have high quality of service, what am I going to do? I'll tend to migrate it up and it will be sticky. If I send it to archive, you know what, I'm going to try to push it down. I don't want that stuff going up. So we want to be able to allow you, the user, to absolutely align the performance with the business value of the data, particularly if you're in a publicly hosted environment. And secondarily, also give the deterministic performance we think is so important to meet the service level agreements of your customers, internal or external customers. That's probably the short version of our vision.
Okay. Global, got one for you. When will Axiom have integration with vSphere and vCenter?
Actually, we've already got that integration with vCenter today. We have a 1.0 plugin which actually allows
the migration to both of those technologies has been somewhat slow. 10 gig iSCSI is beginning to come up more and more. But interestingly enough, for a different reason other than performance, we're seeing that places that have a lot of servers and a lot of connection points, there's port limitations on the 1 gig iSCSI that we have had some larger customers with smaller blade environments want to overcome. 10 gig doubles the connection per port that you can have. So we're seeing that start to come on as an interesting point, but still yet a lot of iSCSI is being driven by essentially by the SMB market. And SMBs apparently still work quite well with 1 gig iSCSI, so the adoption has been somewhat slow. On FCOE, I'm actually a big fan of FCOE. I very much like it. However, what I usually tell people when I entertain this question is FCOE at the moment is a bit of a solution to a problem that hasn't occurred yet. But it will, and it's actually a good technology. It's just taking a little while to introduce as well as we come in. It has to hit price parity, and it's quite expensive to upgrade an existing data center. But all of the trends, as you saw from Roger Cox, have been that it's going to be a little bit of a while before FCOE starts to become pervasive in the marketplace.
Thank you, Mike. Questions in the audience? I have more here, but I want to make sure that we get anything that's dynamic.
Howdy. Based on physical server experience I've had with SAS drives in particular, I've noticed about a 40% increase in failures on SAS drives than SCSI drives. And I guess we can compare SCSI to SATA drives. Anyway, what I'm saying is, are you anticipating a higher failure rate of drives as you start integrating SAS drives into the builder architecture?
I'll take a crack at that one. So I think we've seen isolated technologies or groups of technologies have, unfortunately, high failure rates, almost where you wouldn't have expected. Some of the heat-assisted writing that we've seen in Seagate drives has caused a bunch of problems in the field. And we know it's not just with Pillar. We know it has affected just about everybody. People don't talk about it much because it's uncomfortable. They don't like to hear it. Everyone likes to pretend it's the other guy's problem. But the fact of the matter is heat-assisted writing is very new in the industry. And there's a lot more complex mechanisms that go on that have been introduced into the field with these technologies. And as usual, when that happens, you get new failure modes. And new failure modes are new, so we can't anticipate them all. And I think if you try to net out that question